Well, good afternoon, everyone. My name is Junming, and I'm here to present our research exploring ChatGPT's capability on vulnerability management. Well, recently, large models have been widely used in diverse domains, including question answering, data augmentation, and education. And since there are many similarities between programming language and natural languages, researchers tend to use large language models such as ChatGPT for the code-related analysis. And prior works show that ChatGPT has the capabilities of processing foundational code analysis tasks such as AST generation. However, despite the growing number of studies that apply ChatGPT in software engineering, they mostly focus on several specific tasks rather than the entire life cycle of vulnerability management. And actually, the vulnerability management includes a comprehensive life cycle that consists of the complete phases from the issue discovery to the vulnerability confirmation, and then the vulnerability fixing, and ends with the patch committing. And each phase includes several tasks with unique challenges. This means that the vulnerability management tasks require a deep and all-encompassing understanding of code syntax, program semantics, and related documents. So it is unclear whether ChatGPT can directly assist software maintainers in diverse tasks during the whole vulnerability management process. So to fill this research gap, we explore ChatGPT's performance of various vulnerability management tasks from the following three perspectives. First, does ChatGPT achieve capability on par with the SOTA approaches? Second, how do prompt engineering methods impact ChatGPT's performance? And third, what's the promising future direction to improve ChatGPT's performance on each task? Well, to answer these research questions, we compared ChatGPT's performance to 11 SOTA approaches on 6 vulnerability management tasks, including the bug report summarization, security bug report identification, vulnerability severity evaluation, vulnerability repair, patch correctness assessment, and stable patch classification. This task involves the complete vulnerability management process, which starts from reporting potential vulnerability and ends when vulnerabilities are repaired in the codebase. To achieve this, we first collect the dataset provided by the SOTA approaches of each task. By leveraging this dataset, we evaluate ChatGPT's performance for each task with the same metrics used by each SOTA approach. Then, we investigate the influence of different prompt engineering methods. And finally, we analyze ChatGPT's responses to identify the bottlenecks of each task. For each evaluated task, we develop the prompt templates manually, and the figure on the left shows all prompt templates. The figure on the right shows an example of expertise prompt template. We can provide domain expert knowledge in this prompt with the pink text, and after removing the pink text, the rest represents the general info template, which uses many existing prompt skills, such as giving a role. Next, I will show the evaluation results of ChatGPT one by one. First, in the bug report summarization task, we ask ChatGPT to summarize a given bug report. The results show that ChatGPT can get outstanding performance in this task. And from our user study, we found that in real-world scenarios, ChatGPT has better correctness and readability. The excellent performance of ChatGPT in this task is reasonable since this task is similar to traditional natural language processing tasks, which large language models have shown excellent performance. So the results encourage software maintainers to use ChatGPT for vulnerability management tasks related to natural language processing. And next, in the security bug report identification task, we ask ChatGPT to answer whether a given bug report is security related. And generally, with advanced prompt templates and models, ChatGPT can outperform two baselines. However, it cannot obtain capability on par with DKG. And also, we found that when using the one-shot prompt, ChatGPT tends to mistakenly mark reports that contain unrelated words of the example report as security-related, such as tab and open in the example of the right figure. The results indicate that when providing demonstration examples, how to make ChatGPT focus on helpful information rather than the irrelevant content is an interesting question. Besides, we found that ChatGPT has hallucinations in understanding what a security bug report is. For example, it thinks memory leak and non-pointer dereference are not security related, and these problems lead to the poor performance. Thus, in the expertise problem, we directly tell ChatGPT bug reports related to these problems should be seen as security bug report. Then this prompt achieves the best performance. So the results indicate that developing suitable prompt templates that provide more useful domain knowledge is an efficient method to improve ChatGPT's performance. And in the vulnerability severity evaluation task, we ask ChatGPT to map a function to the CVSS matrix based on its description. And as shown in this table, ChatGPT's performance is slightly inferior to the thought approach. And in this task, advanced prompt templates significantly improve ChatGPT's performance. Actually, at first, we tried from the zero-shot template to the expertise prompt template, but ChatGPT still cannot perform well, so we turned to explore whether ChatGPT can assist us in generating advanced prompts. And inspired by its outstanding ALP capability, we tried to ask ChatGPT to summarize knowledge for this task. The figure shows the process of extracting knowledge by ChatGPT itself from the provided samples. And this self-heuristic prompt improves ChatGPT's performance significantly. So using ChatGPT in a self-heuristic way to improve its performance for challenging tasks is an interesting future research direction. And in the vulnerability repair task, we asked ChatGPT to fix the vulnerable code. And ChatGPT can fix 10 out of 12 vulnerabilities, while the shorter approaches based on program analysis and other large language models can fix 10 and 8 vulnerabilities respectively. And also, we found that the main reason that makes ChatGPT fail to fix the vulnerabilities is insufficient vulnerability-related context provided. So to further improve ChatGPT's vulnerability repairing capability in real-world applications, it could be effective to apply more advanced program slicing methods to provide specific vulnerability-related context. And in the patch correctness assessment task, we asked ChatGPT to determine whether a patch correctly fixed a bug. And generally speaking, with advanced prompts and models, ChatGPT performs comparably to the shorter approaches. And noting that we have three datasets, or two of them only contain the code, while the dataset of Quadrant only contains the description of the patch. And at the beginning, ChatGPT cannot achieve good performance with all prompts that only contain the descriptions of patches without code. So we collect and provide both the code and description in the describe code prompt, and it helps ChatGPT obtain a comparable performance to Quadrant, which means the code of patches plays an important role in this task. And to further investigate the impact of code and descriptions, we add a code-only prompt. And this prompt performs better on most scores, and this indicates that providing patch descriptions even makes a navigate effect in this task. And after manual analysis, we found out an important reason is that when provide both the code and description, ChatGPT tends to analyze whether the code changes match the description rather than the correctness of the patch. So more information is not always better, and guiding ChatGPT to use the information in the prompt in a suitable way is an interesting research direction. And in the stable patch classification task, we ask ChatGPT whether a given patch is a stable patch. The results show that compared to the sorted approach, ChatGPT performs slightly worse. And when analyzing the results with the zero-shot and one-shot prompts, we will observe that ChatGPT tends to report all patches as stable ones. And after manual analysis, we found the reason is that ChatGPT did not understand what a stable patch is. So we provide the definition of the stable patch in the expertise prompt to help ChatGPT understand this text more clearly. And such information significantly improves ChatGPT's performance. So in summary, we conducted the first large-scale evaluation to explore the capabilities of ChatGPT on vulnerability management, and we compared ChatGPT with 11 sorted approaches on 6 vulnerability management tasks with using a large-scale dataset. And our findings show that ChatGPT has excellent capabilities when processing several vulnerability management tasks. And we also reveal the difficulties ChatGPT encountered and shed light on future research to explore better ways to use ChatGPT in vulnerability management tasks. And thanks for listening, and you can get all of other prompt templates and code with the following link. Yeah.
Thank you.